All right, good morning. It's 8 o'clock. So go ahead and get started. I know it's early on a Sunday morning, but let's get some learning done and get this out of the way. All right. So first thing we'll talk about this morning is logical operators. So some of the material covered in this week's class. So what are logical operators? So you can think of it kind of like some comparisons you used to see in math class and things like that. You have things like equal to, double equal sign. That means are two things equal to each other. We have the exclamation point equals. That means not equal to. I'll show you how to use these in a second. We have less than, we have greater than, we have less than or equal to, and we have greater than or equal to. So what can we use these for? Well, we can use these to compare two values together. So for an example, if we did a print 4 less than 5, what is that going to give us? Here, let's make these comments. This is equal to, not equal to. This is less than, greater than, less than or equal to, and greater than or equal to. So what will this do right here? If we print out 4 less than 5, well, whenever you have these comparison operators here, it'll tell you either true or false. So if we put 4 less than 5, is that true or is that false? That is true, right? Because 4 is less than 5. So this will give me true. And then I'm just going to print true. So let's save it and let's run it. Sure enough, we get true printed out. Okay. Likewise, if we put 4 greater than 5, obviously that's false now. If we run it, it tells us it's false. The same thing with the rest of these. We can put 4 equal to 4. Of course, that's true. 4 equal to 5. It's going to give us false, and it does. Let's put the not equal to. This is saying 4 is not equal to 5. That is true. They are not the same. Save it and run it. It tells us it's true. And so on and so forth for the rest of them. We could put, 4, like I said, 4 less than 5 is false, is true. 4 greater than 5 is false. What about this? 4 less than 4. That's still false because 4 is not less than 4. It's false. But 4 less than or equal to 4, that is actually true. And you see that it is indeed true. And it doesn't have to just be with numbers. We can use it with variables. So if I have A is equal to 5 and B is equal to 6, I can say A less than B, which that'll be true because A is the value 5, B is the value 6. And sure enough, it tells us it's true because 5 is less than 6. Of course, if we put equals, that's going to be false because 5 is not 6. It's false. You can use it with a variable and a number. So for example, we have A, we can put 10 here. We can put if A is equal to 10, which is false, or A is equal to 5, which is going to be true. So these operators here are just ways we can compare we can compare values to see if they are true or false. And we'll see in a second here why that's helpful. All right. But you don't have to just do it with numbers. You can do it with a string. We can say this is a string and this is another. Now, if we put A is equal to B, That's going to be false because these strings are not the same. They have different letters in them, right? It starts off the same, but right about here, they start being different. So A equals B is going to be false, and it is. But if we put them as the same thing, this is going to be true now. And it is. So you can compare not just numbers, but you can compare strings as well. Now, can we compare a number and a string? What's going to happen if we do this? A is the number 5, and B is this string. What's going to happen when we do this? It's false, because those two things are not equal to each other. But what happens if we do this? Is this true or false? Is the number 5 equal to the string 5? False. Those are not the same thing. One is the numerical value of 5, and one is a string. It happens to have the character number 5 in it, but it is not the numerical 5. This is the number 5, and this is a string that just so happens to have a 5 in it. So those are not the same thing. So in general, you usually won't ever compare numbers to strings. You'll compare numbers to numbers or strings to strings. That's fine. Let's go back to strings for a second. So what do we have? Little a and big A. Are these the same thing? The answer is no, because a little a is not a big A. Of course, if we make them both big A's, that's true. But a little a is different than a big A. What if we have less than, right? Let's go back to little a and big A. We got less than. What's going to be the answer here? Is little a less than big A, or is big A less than little a? The answer is false. It turns out the capital letters come before the lowercase letters. So whenever I say, little a less than big A, it gives me false. And that's because when you're comparing strings, the big letters come first. And it compares the strings just like you would, you probably learned back in elementary school how to compare words together, right? So we have this, which one comes first? Is this less than this? The answer is no. Just like you learned back in elementary school, you compare each letter against each other until they're different, and they're different here, and then you see what order those are in, right? I'm not going to go over that. Should have learned that a long time ago. But you can compare strings. It's not just less than. You can have less than, you have equal to, not equal, all these different operators we can have. If we have this, it's still going to be false, because this string is not less than that string. All right. So what if we want to compare numbers that someone types in? So we'll have the user type in 2 numbers, right? Enter a number. There we go. We'll have the user input a number and input a number. But if you remember from last week, input always returns a string, right? So if we want this to be a number, remember we have to do integer. That turns this string they type in into a number. Now we can compare A and B as if they're numbers. If we run this, enter a number 1, enter a number 2, It returns true because I typed in a 1 and I typed in a 2 and 1 is less than 2. Likewise, I could put 10 and 3 and that's going to be false because 10 less than 3 is false, right? Okay, so why is this important? It's for what we call conditional execution. Conditional execution means execute this piece of code, but only if this certain condition is true. If the condition is false, don't execute the code. So let me think of an example here. Well, before I think of an example, I'll show you how to do it briefly. All right, so let's say the A is equal to the value 10. Okay. Here's how we do a conditional execution. We can say if A is less than 10, we do a colon, go to the next line, and we have to make sure it's tabbed over. You see how I have this tab on line 12? It's at the beginning, and now I tab over, print, I am here. Let's do this so you can see what the program is. I am here 02. All right, so what's happening here? So first, I'm going to say the variable is equal to 10. A is equal to 10. Now, here's the conditional execution. I'm saying if A is less than 10, I have a colon. If this is true, then anything that's indented right here, I'm going to execute. And it doesn't have to be just one thing. It can be multiple things. You know, as many as we want. So what happens in this case, it'll say A is equal to 10. We're going to say if A is less than 10, that is false, right? A is 10, so 10 less than 10 is false. So because it's false, it will skip all the indented code here. And it doesn't have to just be print statements. It can be anything you want it to be, any Python code. But because this is false, it will skip all the indented. When I say indented, I mean tabbed. It has to be tabbed. Python is very finicky about the spacing in the code. So these are actually tabbed over. So it's false. It skips everything tabbed over. And then it starts the execution again where the code is not tabbed over. So if we run this, the only thing it's going to print is I am here 10. And there it is. I am here 10. Now, if we change this to say 4, now what's going to happen? We'll say A is equal to 4. If A is less than 10, that is now true because 4 is less than 10. That is true. So because this is true, it will execute all the tabbed in code. And then when it gets to the end of the tabbed in code, it'll just go down here to the next line. So when I run this and it's going to print out all of this stuff. We'll see it. There we go. It prints out all of it. That's because it makes this check right here. Whenever we have an if, it'll say, is this true or false? If it is true, all the tabbed code will be executed. And then at the end of the tabbed code, it just goes to the next line. If this is false, it will skip all the tabbed code and just go down to the next line. So we can use that with user input as well. Input, enter a number. So if we run this, if I type in 1, then it runs all of the code because 1 is less than 10. Of course, if I type in whatever that is, it skips all that. So that's how you can control what your program is doing based on a variable. And that variable can be just something you hard code in there, or it can be something the user types in. for example, let's say input, do you want to buy an apple? I'll put in yes or no, right? So we could say if A is equal to, say, a Y for yes, print, you bought an apple. And then we'll still eat the rest of the stuff, okay? So here, we're asking the user if they want to buy an apple, okay? We run it. Do you want to buy an apple? I put yes. And then it tells me you bought an apple. That's because I typed in a Y here. So A is the value Y. I'm saying if A is equal to Y, which it is, that's what I typed in, then print the bought an apple. So if I type in anything else besides a Y, it doesn't print you have an apple, because that was no longer true. That ended up being false. Okay. So that's how the if statement works. One more time, if this is true, execute the tabbed in code. If this is false, skip the tabbed in code. Okay. That's how if works. We have kind of a sister concept that goes along with the if, and it's called else. And it works like this. So I get my input. If this is true, I'm going to execute this. If it is not true, I'm going to execute this. And then we'll have something down here. You are here now, just so you can see it printed out where you are. So if this is true, execute this. If this is false, execute what the else is. So this is basically saying, if this is true, execute, else execute this. Let's see this in action. So if I put a Y for yes, you bought an apple and you are here now. So what happened, I typed in a Y. I said, if Y is equal to Y, which is true, it executes this. And then we're going to skip over this because it wasn't false. We only execute the else if this was false. But since this was true, we execute here, and then we skip down to the next line, which is why we got you bought an apple and then you are here now. So if I don't want an apple, if I put a no, it tells me you did not buy an apple and you are here now. So what happened here? A was equal to the string n, because n is what I typed in. So I'm saying if n is equal to y, and that is false. So since this is false, I'm going to execute what is in the else, which is exactly what you see here. You did not buy an apple. And then after it does that, of course, it goes down to the next line. You are here now. So if true, execute this. If this is false, execute what's in the else. One more to add on to this is what we call the elif. Let me type up a little bit of code here, and then I'll show you how it works. Okay, so how does the elif work? Elif stands for else if. So what is it doing? So for this example, I get the input and I store it in A. So now I'm going to say if A is equal to Y, some of this if repeats itself. If this is true, execute this. and then skip to the next statement after all the if statements. With an elif in here, we're going to say if this is true, execute and then come down here. If this is false, we're going to do the elif. Now we make this check. If this is true, we execute and then we skip to the next line. So you can think of this right here as another if statement with an else attached to it. So let's run through an example. So if I type in y, if I type in y, it's going to say if y is equal to y, which is true, execute that, and then skip down here. Let's see it. Type in y. Of course, it says you bought an apple and you are here now. It's what we expected, right? If I type in an n, what will happen? It'll say if n is equal to y, that's false. So we go down to the elif. If n is equal to n, that is now true. So we execute this, and then we skip down to the next line. So let's run it. If I type in n, that's what happened. You did not buy an apple, and you are here now. That's what we thought. If I typed in an n, that was false. We come to the elif. That is true. So we executed that, and then we went to the next line. What happens if I type in anything else? It printed invalid choice, and you are here now. And why did it do that? Well, let's just do one letter. Let's just say K. K, invalid choice, you're here now. So I typed in a K, so A is the letter K. So I'm saying if K is equal to Y, that's false. So I come to the elif. If K is equal to N, that is also false. So I come down to the else. And this is not an elif. So this is just an else. If nothing above it matched, then we print this, which is what happened with the K. If K is equal to Y, false. If K is equal to N, false. So we come to the else and we print the else. And then we come down to the next line. Have a question? Will Python only execute them in the order they are written? For example, if you swap the position of the else and the elif statement, will the result be the same? You can't do that. If you swap these around, yes, they are executed in the order you put them in. If you do this, you're actually going to get an error in the program. Let's watch. See, you have an error in the program. That's because whenever you use the if and the else is like the final thing. You can't like attach an elif here. An elif has to have a matching if statement, right? The elif matches with this if statement. But whenever you have the else, it means you're done with all of those if and elif statements. So you're trying to do an elif, but you don't have an if to match it with. So once you put else, you can't put any more elifs. The elifs have to come before the else. And of course, the elif, it can't be the first thing either. Because if it's the first thing, it still crashes because there's no if statement above it to match up with. You can leave off the else. You're not required to have an else. So you can have this. You can just have an if and an elif without the else. That works. If I run this, if I put Y, you bought an apple. If I put no, you did not buy an apple. The thing is, if I put anything else, it doesn't give me any kind of message that I did anything, right? So you don't have to have an else. You don't have to have an elif, really. But at least for this example, I think it makes sense to have an else so that, you know, you can give the user meaningful feedback, right? Based on what they typed in for this little example. So you can kind of connect this to your homework assignment where, you know, for your homework assignment, you have to calculate the price of a movie ticket, right? So, and you calculate that based on, are they a child? Do they get the standard price or do they get the senior price? And then you have to say, if it's a 3D movie, there's a surcharge, right? So kind of in pseudocode, I'm not gonna write all the code for you. So kind of in pseudocode, when you say, if they are a child, then the price is equal to some value. Else, if they are an adult, price is equal to some other value. Else, you know, else they're a senior, then the price is equal to whatever for a senior. And then you got to figure out, is it a 3D movie, right? If 3D movie, then you want to add $5 or something to it, right? That's kind of what how your homework assignment looks like. You obviously that's not valid Python code. You got to figure out the code to actually do that. But that's how for your assignment, how this if and this elif stuff kind of connects to it. You'll say if they are a child, then that's the price. Else, if they are an adult, that's the price. Else, the only option left is if they're a senior, right? Else, if they're a senior, then that's the price. And then if it's a 3D movie, you know, you add a surcharge onto it, and then print your price is price, right? That's kind of a little bit of pseudocode for what your assignment is. All right. One more thing I want to cover with the else and else if is you can have them what we call nested. Nested means you can have an if statement inside of an if statement. Let's get rid of these for a second. So, like I said, whatever with an if statement, whenever that is true, it executes all of the tabbed in code, right? And it can be any valid Python code. So you can do whatever you want inside of this if statement. We can even have another if statement. Let's say we want to ask them, do they want a red or green apple? Say B is equal to the inputs, red or green apple. And we use like red or green, right? That'll ask them if they want a red or green apple. So we can have another if statement inside of this one. We could say if B is equal to red, then what do? Print, you wanted a red apple. Else, elif B is equal to G, print, you wanted a green apple. So look at what we've done here. So we have this if statement kind of tabbed over, which means it's part of all this code that gets executed if this first part is true. And so we have another if statement inside of here, and you can see its code is indented, is tabbed in an additional time, right? So if this is true, execute this tabbed in code. Let me get rid of those parentheses. So when I run this, so first of all, do you want to buy an apple? If I don't type in a Y, it skips everything, right? Because that was false, so it skips everything and then goes to the next line. All right, so if we put in a Y, so now it says you bought an apple, red or green. So that was true. So I start executing here. Print, you bought an apple, get input, red or green.
Now, if it's R, it's a red apple. If it's a G, it's a green apple. If it's not red or green, it kind of does nothing. So let's look at that. If we put in R, you wanted a red apple. Run it again. Yes. Green, you wanted a green. Well, apply about apple. If I put in yes, if I don't put in R or G, then it doesn't print out anything. I could have an else there, and we'll print you didn't pick the right apple color, something. Just tell the user something whenever they don't pick a valid choice. We do this. Yes, we type in D for the color. You didn't pick the right apple color. Okay. So that is your if, your elif, and your else statement. Along with, and that's why these logical operators were important, because of what we have here. I've been using the equals the whole time, but you can certainly use any of these comparisons there. It doesn't just have to be equal. You can use not equal. You can use the less than. You can use greater than, less than or equal to, greater than or equal to. And like we did with these comparisons earlier, it doesn't have to be a string. You can use number comparisons, right? Let's do one number comparison, and then we'll move on to the next subject. We'll just say, ask them what their age is. What is your age? That's an integer, right? So we're going to say if your age is less than 6, print you're a kid, right? Else, if A is less than 60, print you're an adult. Else, not else if, it's elif. Else, print you're a senior, right? So you can use number comparisons. So if we type in 1 is our age, it says you're a kid. We type in 8 as our age, you're an adult for some reason at 8 years old, right? And if we type in 77, you're a senior. And why does that work? Because when we typed in 1, it says, is 1 less than 6? That's true. So we print that out. Next, we had 8. Is 8 less than 6? Nope. So we go down to this check. Is 8 less than 60? Yes, it is. So we print that out. And of course, with the last example with 77, is 77 less than 6? No. Is 77 less than 60? No. And then we have the final else. So it didn't match either of those. So we print out you are a senior. So you can do it with strings or numbers. Don't mix the two together. Don't compare a number and a string to each other. It just doesn't make sense. And you can use all these operators if they're equal, not equal, and so on and so forth for these number comparisons. All right. Last thing I want to talk about, and then we'll do questions and answers. All right. Please pay very close attention to this. Every year, at least for the first assignment, half the people don't do it, half the people get it wrong, and half the people lose points for it. Please don't be one of those individuals. We're going to talk about test reports. Starting with this homework assignment, you have to start turning in test reports with your programs. So let's talk about what a test report is. So I'm going to make kind of a crude ASCII chart here, just because I like showing my demonstrations in this format. You should really make your test report in like a Word document table, or Excel is actually pretty good. Excel or some kind of spreadsheet. is actually pretty good for making test reports. So what does a test report look like? So it's basically a table that has several rows and columns. The first column is test cases. Actually, let's see if I got a spreadsheet thing on here. Be easier to show. Yep, got a spreadsheet here. I'll show you in a spreadsheet. It looks better. It's easier to manage as soon as it opens. There we go. Okay, whatever. All right. So really a test report is just a table, which is easy to do in a spreadsheet. So you have 5 columns. Make sure you have all 5 of these columns. You have test case number. You have input. You have expected output. If I can spell right, expected output. You have actual output, and you have pass fail. Let's expand those out some so we can see them all. There we go. Okay. So first, let me describe what the usefulness of this is, and then we'll give an example. So why is this useful? It is useful for finding bugs in your program. It's useful for figuring out if your program is giving you the right answer or not. Meaning we'll list out in this table, we will list out the input we give our program. We will list out what we expect our program to give us in return. Then we'll put what our program actually gave us in return. And then we'll have either a pass or a fail. And a pass or a fail means, is the actual output what we expected? Let's show an example. Let's say we had a program that computes the area of a circle. Okay. You know, the area of a circle is equal to pi times r, right? Pi r squared. That's the area of a circle. That's just math, right? So let's say we make a program to compute the area of the circle, right? So let's get the input. Let's get the radius from the user. Radius is equal to float input, enter the radius. So have the user type in a radius. We'll compute the area is equal to pi. Just keep it at that, times the radius, and they'll print out the area is radius, right? Simple program. The user will type in the radius, we will compute the area, and then we'll print out what the radius is. So let's say that's what our assignment was. Let's put it down here so we can see it. Same time. There we go. Okay. So what would a test report for this program look like? Well, you usually need to have about 5 test cases. Run 5 tests on it. That's a good number. So first, what are we going to use for the input into our program? It could be really any input that you want it to be. We could say we want to do 1, 2, 3, 4, 5. So now we have the expected output. So we know our program is calculating the area of a circle, right? So we need to figure out and this is the key, without using our program, we need to compute what is the area of a circle if this is the radius. You have to do this by hand. You cannot use your program to get the expected output. And we'll see why here shortly. When I say by hand, you can use a calculator. That's fine. But we got a calculator on here. Yep, there's a calculator. So if the input is 1, what is the output? 3.14 times 1 times 1. So our expected output would be 3.14. I'm gonna cut this just down to 3 so we save time. So now if the input is 2, what is the answer? So it's 3.14 times 2 times 2. So we expect that answer to be 12.56. If our input is 3.14 times 3 times 3, we expect the answer to be 28.26, right? This portion of the test report should just be done completely by hand, and you need to compute this expected output by hand. Foot stomp right there. And I'll talk about why in a second, but make sure you compute this by hand. Okay, so now we need to get what is the actual output. And how do we do that? We actually run our program. We will put that input into our program, and we will record the answer in the actual output. So if we run our program, if we put the input as 1, our program says the area is 1.0. Oh, actually, that's a good point. It should be area, not radius. I actually just proved the point of the test table. All right, enter the radius, enter 1. So it says the area is 3.14. Okay. If I put the input as 2, it tells me it's 12.56. If I put the input as 3, this is tricky right here. And this is acceptable though, but you can put 28.25999999, whatever. I'll tell you why that happens in a second too. So, okay, so we got our output from the program based on those inputs. So now, did it pass or fail? So is the actual output the same as the expected output? Yes, it passed. Is this output equal to the expected output? Pass. This one's tricky, unfortunately, for really any programming language. Is this output the same as this? It actually is. And this is a failure of really any computer. It's not just Python, it's any programming language. I'll explain to you why we get this number that's a little bit off, but for all intents and purposes, these are the same number. Okay, so that's passed. So that's all there is to a test report. Is the test case number, those just go up sequentially, the input you give the program, the expected output, the actual output, and then whether they pass or fail. So why is this useful? It's useful to catch a bug in your program, right? And I actually showed it a little bit earlier. So let's delete those off here. So let's imagine I have a bug in my program. Okay. Let's imagine instead of radius times radius, I just did that for the area, right? That is not computing the correct radius. Excuse me, that's not computing the correct area, right? This is a bug in my program. This is pretty easy to spot when the program is 3 lines long, but if you have 3 million lines of code, this could probably easily get overlooked. And that's what a test report is for. So let's imagine I have this bug in my program. Now I'm going to run my test cases. So let's go back. When the input is 1, it tells me the area is 3.14. Does that pass or fail? That actually passes. Okay. Let's use the input of 2. It says 6.28, 6.28. Oh, that fails now, right? Because the actual output does not match the expected. Let's do the last one. Let's do 3, 9.42, 9.42. That fails as well. So what is this telling us? If we have fail in this column, that means there is something wrong with our program. Our program has a bug in it and we need to go fix it. Right? So when you're running your test report, if you get a fail in this column, you need to go back and fix your program because it's wrong. And so I see the fail and I look through my program and I recognize, oh, that's not right to do the area, that's correct. Okay. So I go back, I correct my program. Whenever I correct my program, I need to remove all of these, all this portion of the test report, because I need to run my program again. I need to test it again to make sure I fix the problem. Maybe I put 2 there. So if I put a 2 there, it's still wrong, right? So whenever I run my test cases again, I get 6.28 for the first answer. That's a fail. Well, I can already tell there's something wrong with my program because I got a fail. So let me go back and fix my program. I go back, look at my program again. Oh, this is still wrong. I change it to that. I think this is right, but let me go run my test cases again. So now if I run my test cases with 1, 2, and 3, it tells me that the output is 3.14. It tells me it's 12.56, and it tells me it's 28.5 and a bunch of 9s. And now they all pass. And when all my test cases pass, it's a very good indication that my program is functioning correctly. Okay. Now here's where you can go massively wrong. And if it's easy for me to spot when you make this mistake. And when you make this mistake, it's not really a mistake. You have purposefully done something wrong. So if you make this mistake, I will give you a 0 for the test report because you are defeating the purpose of a test report. So what can you do to get 0 points for a test report? Okay. Let's say I have a bug in my program. Let's see, that's the bug in my program. Okay. All right. So whenever I'm filling out my test table, I only do these 2 columns. I only do the test case number and the input. Now, again, reminding you, this is what not to do. And if you do this, you will get 0 points for the test report. So let's say I just do this part. And I don't really feel like manually calculating what the output should be. I know my program is right. I know it's given the right answer, right? I'm saying that facetiously because obviously it's wrong, but I don't want to go through the trouble of manually calculating this expected output. So I just run my program. I put in all the inputs. Okay, the first one is 6.28. Oh, that's the expected output, and it's the actual output. 2 was 12.56. And 3 was 18.84. All the values match, so it's a pass, right? What have I done wrong here? Instead of manually calculating what the expected output was, I just assumed my program was correct. And so whatever the actual output of the program was, that's just what I put for the expected, because I can't make a mistake, right? So you see what you've done wrong here is your outputs match, and you said it passed when there's obviously an error in your program. And so you may ask yourself, how do I know when you have done this? I know you have done this when the expected output is not what the expected output should be. So if your assignment was to compute the area of a circle, if your input was a 1, I know that's the wrong answer. I know the area of a circle with this input is 3.14. So when you have this right here, it's extremely obvious that you did not manually compute this expected output. You just took whatever your program told you and you put that for the expected output. And so because you did this and because you get passes here now, you think you did it right, but you did it wrong. So if you do this, for one, you'll lose points for having an incorrect program, but I'm not going to give you any credit for your test report because you completely missed the point of the test report. The point is to catch this problem right here, is to catch wherever the other ones are, 12.56, 28.26. The point is to catch when these are not the same and to recognize your program is wrong. All right, so that's what your test report should look like. You have to do it for this assignment this week and all future assignments. So make sure you have all of these columns and all this information filled in. And you should have at least 5 test cases, at least 5. Okay, and as far as your assignment, I already covered a lot about for the assignment. You can go back and watch some of the earlier video whenever I post it about having to determine, how old is the person, so how much should you charge them for a ticket, and then you have to charge them extra money, if they want to watch a 3D movie. All right, so I'll go ahead and open it up for any questions. You can unmute your mic and ask, or you can put it in the chat channel.
Good morning, Professor. Can you hear me?
Yes.
I was just wondering if you were familiar with during the extra reading assignment this week, that book talked about something called the walrus indicator, or sorry, the walrus operator, which was like a colon followed by an equal sign, and it kind of acted like an assignment and a comparison at the same time. But I think the book didn't really do a good job of explaining it. I was wondering if you were familiar enough with it to maybe like give us an example.
Actually, I'm not overly familiar with it. It's not something I use. That's only been available in newer versions of Python. Now I would have to get back to you on that. I'm usually stuck on Python 2.7 or 3.7. I haven't used the newer Python stuff. So I guess you kind of got me on that one. I don't know the answer to that, but I'll research it more and I'll send out an email about it.
Okay, no worries. Thanks. I was just wondering because, like I said in the book, it just briefly went over it for like maybe 1 or 2 sentences, and then it breezed past it. So I was kind of confused. But
Yeah,
okay, I appreciate it. Thanks.
it's something probably within the last year or so introduced to Python, so it's fairly new. All right, I'll stick around for another minute or two. If you have any questions, just bring them up. I will. This is being recorded. I'll get it uploaded to YouTube and get the link posted out out to the class here in the next hour or so. All right, I'll take a couple minutes to talk about this walrus thing. I just read up on it and see what it's doing. So it's doing like an assignment and a comparison at the same time. So all right, earlier we had A is equal to the input. Do you want an apple? You know, kind of yes or no. And then we said if A is equal to yes, then print you bought an apple, right? It's kind of like three. Okay, good, I'm not on mute. It's kind of like 3 lines to do something, right? So when we run that, do you want an apple? If we put in yes, it says you bought an apple. So what this walrus operator, I don't know why they gave it that name. So you can kind of combine these 2 statements right here into one. And here's what it looks like. So we can say A is equal to so we say A is, I guess, colon equal to, I don't know if you would say a walrus or what. So say A is equal to the input. Do you want an apple? Yeah, kind of yes, no. And then we can say if that is equal to yes. Kind of like this right here. Yeah, I think that looks right. So here you're going to say A is equal to, if I type in yes or no, and then you're going to say, is that yes or no equal to yes? So save it and run it. You want an apple? Yes. Prints out you bought an apple. If I put in no, it doesn't print it out. So really it just looks like a shortcut. So you have that, or let me finish typing this real fast. All right, so those 2 things do the same thing. These 2 are identical to each other. I guess this just reduces the number of lines by 1. So instead of taking 2 lines to do that if statement, it just does it in 1 line. Personally, I don't see the point of doing that. It's just my opinion, but I guess it's there and available for you to use if you want to. So that's what it looks like. This walrus is it says A is equal to that, and then it says we can use that A for this comparison there. Yeah, seems
Okay,
kind of,
thank you. I get it.
seems kind of pointless to me.
Yeah, it seems a little more confusing to me, but I guess it saves a line.
In my opinion, saving a line is not worth it. Having readable, understandable code is much more important than how many lines it takes to do it. I got a question. I missed the beginning of the video. Did you cover the plus equals operator? I didn't do the plus equals, but I can do that real fast. So at the beginning, we had equals, not equals, so on and so forth. Actually, I think the plus equals was last week, because the plus equals isn't a comparison. It's a shortcut for addition, really. So say A is 5, and let's say I want to print out so we see the value. Let's say we want to increase it by 1. We can have A is equal to A plus 1, right? And if we print A again, A should be 5 and then 6, right? If we run it, there we go. A is 5 and then A is 6. So there's a shortcut for this. Instead of A is equal to A plus 1, we can just say A plus equals 1. And that's just a shortcut for it. Is equal to A plus 1. So we just comment that out. These 2 lines do the exact same thing. One is just a shortcut for it. So that's all the plus equals is. And there's a plus equals, there's a minus equals, times equals, and divided by equals. And they do just what you expect. So a divided by equals 1 is the same thing as a is equal to a divided by 1. Those are the same thing. It's just one is a little bit of a shortcut for it. Other question, can we still access the previous video? Yeah, absolutely. I don't take the videos down or anything. So just go back to the email that had the link, or actually the videos are posted on the course homepage. So you can always go back there and access all the previous videos. All right, go ahead and wrap this up. I'll get this posted up on the course page here in the next hour or so. If you need any help or assistance with your homework, I don't know unless you ask me. So the preferred method is via email, because I'll get notifications on those, and I can usually get you an answer back same day. All right, everybody have a good rest of your day.
You as well, Professor.